All right, so find the derivative if it exists of the function at the specified point. So something like 24 f of x is equal to 2x plus 1/2 x squared at x is equal to 2. So derivative at a point, we're doing, again, we're taking the limit. So we're using f prime of, well, at a, so this is a, 2 is a. So f prime of 2 is equal to, and now I'm doing the one that's derivative at a point for the easier computing one. Okay, just so you know, I'm not rewriting the entire formula.
Okay.
For the limit as, why is this? H approaches 0 of, it's f of a plus h, so it's going to be, hold on, I'm just going to write the formula over here so that we can see it, because it's just, I like to have it in front of me. It makes it easier. All right, and it's the limit as h approaches 0, but that's what's happening. So I'm plugging in a plus h anywhere I see an x. So 2 times a plus h, so 2 plus h plus, I still have to do the second part, 1/2 times a plus h squared. Now, that's just accounted for this first part. Minus f of a, so anywhere I see x, now I'm just putting a 2. So 2 times 2, and this is minus this whole thing, so I'm going to bracket this off so that 1/2 times 2 squared all over h. Okay, are we tracking so far? Not at all. Okay, write it down first and then I'll go back through it. Y'all are going to be really mad when I tell you this can be done by a shortcut too, aren't you?
I've just accepted that probably always a short.
It's generally true. Okay, so I'm following the formula, so it's f of a plus h. That's what I do first. So in this entire function, everywhere there's an x, I've got to put a plus h. So I had 2 times a plus h, a was 2. So in this situation, a is 2, so that's why it's 2 plus h. Plus, I still have to do this piece, 1/2 times a plus h. Oh, I should have written a 2 here, not an a.
Oh,
Hold on.
so
I wrote an A here originally, rewrite it as 2.
you said wherever x is, you put what?
Right now we're putting A plus H for X. So remember when we had like f of 2 and the function was like x squared plus 3x? We would do, okay, this is 2 squared plus 3 times 2. That's what we're doing. We're just now doing 2 things are getting plugged in, like a plus h, which is, in this case, 2 plus h is what's happening.
2 times 2 plus h was 1. Oh, okay.
So that's the first part. So I've done the a plus h part. So now it's minus f of a, but I put it in brackets because there's multiple pieces here. Okay. So
Did you like?
So where
anywhere now that there's an x, I'm going to just put a, which is 2.
So where did the 2? So like in the bracket, the 2 times 2. So is the 2 the f?
So 2 times f of 2,
Okay.
because it's f of a. So now I'm putting in 2 for x. So anywhere there's an x, a 2 is going now.
So for the minus f of a, you have to put it all into like the.
So what actually occurred here for the top of this is 2 times a plus h plus 1/2 times a plus h squared minus 2 times a plus 1/2 times a squared. That's what is actually happening on the top. I just went with numbers right away. But formula-wise, that's what's plugged in there. Maybe that will help. Probably should have started there.
Like, so,
Obviously, all over h. But
since there's two things you have to plug in, like the a plus h and then just the a, so you have to, you plugged in the a plus h first into the equation, and then you have
and that was this.
Yeah, and then you have to write it again, but replace the x's with just the a.
Yes, which in our case is 2, which is why it's like this.
Okay.
Yeah, y'all are gonna be real mad when I show you the easy way to do
Like
this.
the last part was the part that was confusing me because I'm like, where did that 2 times the 2 come from? But I think I see now because I didn't realize we had to put that back into the.
Yeah. I realized like probably should back up here and do this again. Because the one we did in the example was a little different because it only had one term that had it and the other one was just a constant term.
Yeah. Okay, that makes sense.
Okay, so now I'm going back to this blue part. I'm going to just multiply stuff through and try to simplify it as much as possible. So I have the limit as h approaches 0 of, okay, this is going to be 4 plus 2h, okay, so that's this first piece, plus 1/2, or well, actually, hold on. Write the 1/2, and then we're going to rewrite that as it's a perfect square trinomial. So 4 plus 4h plus h squared minus, now notice this minus is going to both things, so I'm going to go ahead and like already multiply like it through. So minus 4 minus 1/2 times 4 would be 2. All over h still. Are we still tracking?
Yes.
Yes.
Okay.
Better.
Better than the first
This
step.
seems like the easy one.
Okay, so now limit as h approaches 0 of
I have to label my steps.
all right, well, I'm going to see what I can cancel here. So 4's cancel. So 4 minus 4 cancels. At the moment, I don't yet have something else that can cancel. I will, but so now I have 2h plus, now this 1/2 has to get distributed to all of that. So 1/2 times 4 is 2. 1/2 times 4h is 2h. And then plus 1/2 h squared minus 2 all over h. So 2's cancel. I have now limit as h approaches 0 of 4h plus 1/2 h squared over h.
Do you want to take an h out of the top?
Yep. If I don't, then I still have a 0 on the bottom. So I can't leave it like that. So that's why. So limit as h approaches 0 of h times 4 plus 1/2 h over h. So I'm just going to save a step. H's cancel, plug in 0 for h, and you are left with 4.
Okay.
Now you want to know the shortcut.
Wait,
Well,
what happened to the 1.5 page? It's just 4?
Because when you plug in 0 for h, it goes
Oh.
away.
I forgot. Oops.
So that goes to 0. And a lot of times when something goes to 0 because of the limit, I will actually draw an arrow and put that it's going to 0 so that, especially if I'm going to like kind of skip the step that I skipped. You could have just rewritten it as the limit as h approaches 0 of 4 plus 1/2 h, but I figured we can save a step of writing on that.
So I think like the hardest part on these problems is just like making sure you set it up.
That part?
Yes, that part.
Setting it
That
up
part.
correctly and then
Just
after
plugging
that.
it in.
All right, so I'm gonna make you mad now, probably.
You probably will. Like,
All right, so the problem originally was 2x plus 1/2 x squared. This thing is glitching, so don't try to earn a cookie point or it's not writing. At x is equal to 2. It's like
That's crazy.
it's like invisible ink. So this was f of x. Okay, take the derivative the shortcut way. What's the derivative of 2x? What exponent's on x right now? 1. So if I put the 1 out front,
Wait.
it's 2. 1 minus 1 is
0.
x to the 0 is.
1.
So this is equal to 2.
Okay.
Whoa.
I got it. Give me a second. Just give me a second.
Plus, what's the derivative of 1/2 x squared?
Oh no, I see where this is going already. No,
Cancel out. So
2x. No,
X
that's
to the
wrong.
1.
So it's just, you're just left with x because you would put the 2 out front, that would cancel, you're left with x to the 1. At x is equal to 2, 2 plus 2 is equal to 4. And we're done. Now I have a really trick question for you because we're almost out of time, so why not give you some more fun facts about derivatives? We don't have time to do another long problem, obviously. What's the derivative of -3?
I'm so bad at this. 'Cause
Undefined.
I'm so bad at doing this.
Wait.
Yeah, I don't think
I don't know.
I can't do this.
Maybe if it'll start. Wait, give me a second.
And they get 3.
How did that
I don't know.
go?
Wait,
That makes sense.
because yeah, it's
I was
negative,
gonna
right?
say that.
There's no x term.
Yeah.
Right. Oh.
So it's.
So now I have another question for you.
what it is,
And
so
Jake, you can get your brother with this one at
so
home
the
tonight.
derivative is 0?
Yeah,
So
if
it's-
it
What's the derivative of pi?
Undefined.
The derivative of pi is
Christian.
0. Undefined. Yeah.
0. Because pi is what?
3.14.
A number.
Yeah.
Last year that's why I said you can get your brother with this one. I put, what is the derivative of this on a calculus test? And his brother put that. And I'm grading it and I said, what is pi? And he looked at me and I said, it's number, correct? And he was like, don't make me sad.
Try not to. I'm not.
The derivative of pi is 0. So the derivative of a constant term is 0.
So if there's no x term,
No x term, it's 0.
are there any undefined derivatives?
I can't think of one off the top of my head, but I'm not going to say it's not possible. So, anyways, there are other rules, obviously, but well, we'll do more examples tomorrow. I'll go through and figure out exactly which ones I want to do and which method I'm going to make you use to do them.
What's the derivative of x? Is it just x to the -1?
The derivative of x.
Yeah.
So what's the exponent?
-1.
0. Wait. 1.
1.
So
X to the 1 minus 1 is
Minus 1.
Y. Minus 1.
x to the
0.
0.
Which is 1. So the derivative of x is 1.
Oh, I was thinking.
So it's just 1.
Oh, I was thinking about like x to the 0, but like
Then that's just 1.
that's just 1. So would it just be 0?
So then it would be 0 would be the derivative, right? Because that's just a number.
Correct.
Okay. Yeah.
Whoa!
Wow.
Wow, chapter 3 of calculus done.
Forget about it all tomorrow.